Welcome back to our series on statistical methods. I'm Mark Ledbetter. This is Lecture 3. We are in Part 4 of Chapter 2, and we're in the overall section ANOVA, Design of Experiments. So previously we've talked about the models, the assumptions, errors, and then we talked about the 5 different steps of the hypothesis test. So in this video we want to give you an example using all of those steps. So this is the Portland cement example. We have an engineer who has put a latex emulsion chemical, emulsifier, into the mortar mix in order to speed up the setting time, the cure time for this. But there's a concern that the tension strength of the bond tension strength of the mortar may be lowered, which is not a good thing. Okay, so there were 10 samples of each condition. This is the original or unmodified recipe, if you will, and then the new recipe or the modified mortar. And so 10 samples of each. So N1 is equal to 10, N2 is equal to 10. And so these 10 each samples were prepared and then they were measured. Okay, and so we have Y1 bar, S1 squared, the square root of that rounded to 3 decimal places, and then the same thing for the unmodified mortar. Now, suppose that the standard deviations are known and that they're equal. Again, this is not very realistic, but this is what we're being told for this problem. So we're going to do this problem under that assumption. So we need to write the hypothesis statement here. And so we're going to say H naught mu1 equals mu2 versus H1 mu1 is not equal to mu2 in the model, or using the model, or under the model, however you want to say that, Yij equals mu I plus epsilon ij, comma, I equals 1 to 2, j equals 1 to 10. It's the same for both, so we can just say 1 to 10. Okay, so it's balanced samples. And then using alpha equals 0.05. Okay. All right. So unless otherwise specified, we're going to use alpha equals 0.05. Now the test statistic, because we are saying that we know the variances, we're going to use z sub naught. Okay. Even though n is small, it's 10, we're saying we know sigma 1 and sigma 2. So we need to plug in. And so what we're going to do is we're going to take y1, which is 16.76, minus y2, which is 17.04. Okay. And then we're going to divide by the square root of, and we'll say 0.3 squared over 10 plus 0.3 squared over 10. All right. We know sigma. We're going to plug in sigma here. And we've said we know them and that they're equal. Okay. So under these assumptions, this is how we would calculate it. So 16.76 minus 17.04 is negative 0.28 divided by, and then we have the square root, and so it's 2 times each of these, right? Because there's 2 of them. So we have 0.3 squared times 2 divided by 10 equals 0.018, and so we have negative 0.28 divided by the square root of 0.018, and we get negative 2.08 699. Okay, and so we're going to, for a z table, we're going to say negative 2.09. Oops. And this is the value of our test statistic. Now, the critical region, all right? And so we are saying in the critical region, this is going to be, we look at our critical region and we say, okay, it's going to be Z naught is less than negative Z sub alpha over 2, or Z naught is greater than Z sub alpha over 2. Okay. Now, alpha is equal to 0.05, and alpha over 2 is equal to 0.025. All right? So we want Z sub 0.025, and so we can look this up. So remember that if we have 0.025 over here, that the cumulative has got to be 0.975, 0 to 4 decimal places. And so we go to our Z table. In this case, we can look up the cumulative of 0.975, and we find that that goes with Z of 1.9 and 0.06, so 1.96. These tables are just portions of the table from your book, okay? So we find that Z, this is Z sub alpha over 2 is 1.96. So what we do is we plug in. So here's the first statement. Now, I'm going to use this statement because Z is less than 0. This is negative. So I've got negative 2.09 less than negative 1.96. And that is a true statement. Now, if Z was positive, then I would use this statement, but this makes no sense, does it? If I want to plug it in too, I can, but it's kind of ridiculous. Negative 2.09 is greater than 1.96. That is not true. This is a negative. So we don't have to use, you don't have to show both of these. I do want you to write down this as your critical region. You write down both. But then, you know, Z naught is less than 0. Therefore, you're only using this one. This is the only one that can be true. In this case, this is true. So we're going to come to our decision. Since that is true, we're going to reject H naught. Now, the other way to do this is to look for 2.09, negative 2.09, and find the p-value. And so here's 2.0, and this is, let's see, so this is the cumulative. This is only table 1, okay? They didn't show us table B, so they just have table 1. And so this is, so 2.09. So in this case, the only way I can do it, now table B gives me this area directly. But this is 0.98169. So this is going to be 1 minus that, 0.98169. So 1 minus 0.96189, or no, did that wrong, didn't I? 1 minus 0.98169, there we go, is 0.01831. Okay. So my other critical region could be that the p-value is less than alpha. Alpha is 0.05, and then the p-value is 0.01831. That is true. So if you're going to reject with the critical value method, you will also reject with the p-value method. They are equivalent. You never get the same different decisions using different ones. You always get the same decision regardless of which method you use, as long as you don't make a mistake. Okay? So I want to point that out. They're both equal. One is not better than the other. It's whichever one you prefer. And when computers are used, they use the p-value method. And so that makes it easy for us to just see, oh, is that less than alpha? Okay. So in either case, regardless of which rejection criteria we use, we're going to reject the null. Since we have rejected the null, there does exist sufficient evidence to support the claim that the tension bond strength of the modified mortar with emulsifier, latex emulsifier, is different than, let's see, is this, oh yeah, than the tension bond strength of the unmodified or original formula for the mortar, modified mortar formulation. Now, we really should use mean. The mean, I should have used the word mean because we have mu. So the mean tension bond strength of the modified mortar is different than the mean tension bond strength of the unmodified mortar formulation at a alpha equals 0.05, so 1 minus alpha equals 0.95 or 95%, so 95% confidence level. The test was performed using a simple random sample of size n equals 20 or n1 equals n2 would be more, n1 equals n2 equals 10, n equals 20. And that tells the reader everything they need to know about the sample size. Okay? So that is the example using this assumption. Okay? In the next videos, we'll do this example over again using other assumptions and see what the how the calculations change. Okay, so I'm going to walk through all all four of the different ways to do the problem. Okay, so you'll have an example of each way, and with the same data, so you can see, you can compare if you like. All right. So if you have questions, come to virtual office hours. If you need help before then, by all means, email me. I will do my best to get back to you as quickly as possible. So as soon as I can, I will get back to you. Please take care of yourself because we hope to see you next time.